My name is Kelly Pavel, Technical Manager for Invino Engineering, LLC. We're an international engineering firm specifically for steam and condensate systems. Today, I'd like to talk about the deaerator that's located in the boiler plant. And the question is the deaerator operating at design specifications? And also, why and how to test the deaerator for performance. Performance. A deaerator is really a critical device for the steam system to prevent corrosion, specifically the boiler operation, but also for the steam and condensate system. And the question is the deaerator working correctly? For inner operation, at least 27% of the new deaerators installed by our engineering teams fail to meet the performance standard, which is 7 parts per billion dissolved oxygen. And even a higher number of operational units in the field do not meet the performance standard. And the question is why a high number of non-performing deaerators? Truly because of lack of deaerator performance testing or dissolved oxygen testing for the deaerator performance. The deaerator operation, high quality water is required for the boiler operation. We have to remove the non-condensable gases or eliminate them. Eliminate corrosion in the boiler and the steam system is the result of having a performing deaerator. The deaerator performance is measured in units, parts per billion. International standard, 7 parts per billion. It's also an ASME standard to have 7 parts per billion operation for dissolved oxygen. 2 types of deaerators. Tray. Agitation is provided by spilling water over stacked plates or trays. Steam is injected into the tray section, or an atomizer or spray type deaerator. Condensate makeup water is sprayed through the set of spray nozzle, and the steam is injected to help the process. Deaerator venting. All deaerators must vent non-condensable gases. A percentage of steam is vented to ensure the removal of non-condensable gases. Question is, what is the correct amount of vented steam? Technology methods of testing deaerator performance. If we have steam coming out, the deaerator is performing. That's not true today. It was always said a small plume of steam, 14 to 18 inches. A small plume is good, then a larger volume must be outstanding. And that causes unnecessary loss of energy. It has no bearing on true deaerator performance. Testing the deaerator performance is by sulfite residual. Easy to do on a daily basis, but it only tells you have sulfite there. Negative is not a true measurement of non-condensable gas elimination. Deaerator can have sulfite residual, but fail to remove all the dissolved oxygen per the test. For performance testing, test is done to the ASME standard PTC 12.3. Sulfite is removed from the deaerator operation for 40 hours prior to the testing. So we have true deaerator performance without any effect of sulfite. In our test, we want to be 7 parts per billion or lower. We should be doing this test at least every 6 months, and the larger deaerators are online monitoring now. Performance testing. Conduct dissolved oxygen testing. Adjust the steam venting based on dissolved oxygen test. Example, if you have a reading of 3 parts per billion, steam venting can be reduced. Reading of 30 parts per billion, steam venting may need to be increased or needs to be increased. Steam temperature can be adjusted to assist in lowering the dissolved oxygen content. We always say a deaerator should operate at 6 psi. That's just a ballpark number. It can be 9 psi, can operate at 5 psi, 15 psi, even today if deaerator is operating at 100 psi. It's just to make sure that the deaerator is getting rid of the non-condensable gases. The other thing for deaerator sampling or doing the test for dissolved oxygen, you have to have proper sample preparation. Typically, the best is a central testing location and a proper sample cooler. The other thing is making sure that all the valves components meet B31.1. The other thing is that shutdown on the annual shutdown, all deaerators internals should be inspected: spray nozzle, springs, trays, internal tank. The other thing is visual inspection, if possible, to actually video or take pictures of the spray action. As you see in this picture on the right-hand side, not very good spray. We want the spray to break up the water in very, very small droplets so that we can get the non-condensable gases to come out of solution. So this deaerator was definitely not performing to standards. The other thing is that today we have online meters. So we really want to be watching our dissolved oxygen or performance of the deaerator. There's a multitude of manufacturers today that provide these type of meters. Very accurate and ensures proper operation of the deaerator. At the end result, we must make sure the deaerator is meeting performance. So we want to be at 7 parts per billion or lower without sulfite being added to the chemical process. The other thing is you can come to our website and there's more detailed information up there, along with 70 best practice, 28 articles, and 24 more instructional videos like this one here. The other thing is that anytime you have needs or requirements for assistance in steam and condensate systems, please contact us. We have short-term impacts with this engineering assessment, steam balancing, steam reliability, and steam engineering training. Long-term implementation, engineering, project design, project management, and full engineering support of the steam system. Thank you for your time today. Hopefully this will have been of help to you. Have a great day.